In this video, we'll take a look at solving inequalities that have more than one operation, and you'll see that we can use the addition and multiplication principles together to solve inequalities, much as we did when solving equations. In this first example, we have a denominator of 5, and our first procedure when we solved equations was to eliminate the fraction. So to maintain our inequality with an equivalent expression, every term needs to be multiplied by 5. Simplifying, we have a 10 greater than 45. The 5's cancel out, the 5 in the numerator canceling out the 5 in the denominator, leaving negative x. Next, we have the variable on one side. Moving the constants to the other side, we will subtract a 45 from each side, leaving us with a negative 35 greater than negative x. This negative x is short for negative 1x, and just as with equations, in inequalities, we want a positive 1 coefficient on our variable. We can either multiply both sides by negative 1 or divide both sides by negative 1 to cancel out that negative, but this is the special case for our multiplication principle for inequalities. If we multiply or divide by a negative, we must reverse the direction of the inequality. Simplifying, we end up with a positive 35, and negatives cancel out. 1 over 1 leaves the x. An equivalent inequality to this, bringing the variable to the left, would be x is greater than 35. Interval notation would be the following, and to help us see that, let's do a quick graph of this. We are not including 35, so we use a parenthesis, and x is greater than 35. It's headed towards positive infinity. So if we wanted an equivalent interval notation, starting with the smallest value first and then largest, using the appropriate symbols, here would be our equivalent interval notation. In this next problem, if we follow our solving procedure, we're going to eliminate those parentheses first. So using the distributive property allows us to replace this quantity with 3 times x and 3 times 9. Similarly, we will eliminate this parenthesis by multiplying each term in the parenthesis by the negative 5, and it is a negative 5 if we use the rule of subtraction. Subtraction is the same as plus a negative. So we have a negative 5 times x is negative 5x, and negative 5 times a positive 6 is a negative 30. Either write it as minus 30 or plus a negative 30. Simplifying further, our next step is to simplify both sides by combining like terms. We have integers, negative 27 minus 1, or plus a negative 1, which leads us to a negative 28 for an equivalent value. On the right-hand side, we have 2 minus 30, or plus a negative 30, which is going to leave us with our negative 5x and a negative 28. We have variables on both sides. Our next step is to get the variable on one side. One option would be to add 5x to both sides, leaving us with an 8x minus 28. The 5x is canceling out, and just the negative 28 on the right. Next, to get the variable by itself, to undo the subtraction, we'll add 28 to both sides. And the numbers don't disappear on the right. The left is 8x, but on the right, negative 28 plus 28 is 0. Continuing on, solving for x, we will divide both sides by 8, our final step, and since it's positive, we don't have to worry about changing the direction of the inequality. Simplifying, the 8's cancel out, leaving x, and 0 divided by 8 is 0. So our solution is x is less than 0. If we need an equivalent interval notation for this, to illustrate that, let me draw a quick graph. X is less than 0. So here's our 0 on the number line. We're not including it, and we want all the values that are less than that, continuing towards negative infinity. The interval notation, we start with the smallest value, which is that negative infinity, to our largest value, infinity always parenthesis, and because this was just an inequality without the equal to, we'll use a parenthesis.